We have a molecular equation of a double displacement precipitation reaction, and we want to write the complete ionic and net ionic equations. To do this, we're going to break all our aqueous ionic compounds into cations and anions. So sodium sulfate will produce 2 sodium ions, plus a sulfate ion, plus calcium ion, plus 2 iodide ions, the calcium sulfate product is a solid, insoluble, so this is not going to be broken apart. This is not in solution. We're going to break apart the sodium iodide into sodium ions plus iodide ions, 2 iodide ions, so this is the complete ionic equation that shows everything in solution. To get to the net ionic equation, we want to remove what is not participating in the reaction. So remove what is identical on both sides of the equation. And we have 2 sodium ions on both sides of the equation and 2 iodide ions on both sides of the equation. So the net ionic will have the rest of that reaction. So it is the sulfate ion reacting with the calcium ion to produce the insoluble calcium sulfate. For the next reaction, we want to identify a precipitate. Well, first we have to identify what products we're going to have there. So as a double displacement reaction, we take the cation of the first, combine it with the anion of the second, cation of the second, combine it with the anion of the first, making sure that we write it with the proper subscripts. We're doing sodium with nitrate. Sodium is a +1, nitrate is a -1. So we're going to have 1 of each, NaNO3. And we're going to have 2 of them, since we have 2 of both ions. The other compound is barium with sulfate. Barium is a +2, sulfate is -2, so again, 1 of each. So now we have to identify the physical states. Sodium nitrate. Sodium is always soluble, nitrate is always soluble, so this is a soluble product, or aqueous. Barium sulfate. We don't have any direct rules in barium. Sulfate is generally soluble, but it does have some compounds that it forms precipitates with, including calcium, strontium, barium, radium, silver, and lead 2. So barium is one of the compounds that will precipitate with sulfate. So this is our precipitate.